Hi there, thanks for joining me again. Right now we're going to start talking about percentiles and correlations. We're going to talk about percentiles first and then correlations, and we're going to be describing how you go about calculating them and interpreting them. All right, so when we think about percentiles, we're talking about the value below which a percentage of data falls. And that can be a strange concept to really think about, but in general, examples help. So what you're looking at right here is a grouping of people by height. So you can see on the left, this little blue person is quite short, and on the far right, we've got a significantly orange person that is quite tall, and they're ordered sequentially. So if you are the fourth tallest person, so if you're this, blue lady right here, then you are saying that you are in the 80th percentile because 80% of the people are shorter than you. All right, so again, if you're the fourth tallest person, right, 1, 2, 3, 4, in a group of 20, 80%, right, so 19 of those people are shorter than you, that is 80%. You are in the 80th percentile. So when you remembering this normal distribution, we then have all these different standard deviations where we're able to describe how data fall on either side of the mean. Do you remember this? I hope that you remember this. Now remember, when we last talked about this, we said that, well, this allows us to talk about percentiles too, but I didn't really talk about how that worked. Well, here it is. So when you lay this out, you start looking at percentile and cumulative percentages of the normal distribution. So when you look at percentiles, so this is my little star here, we're saying 1%, 5%, 10%. And so we keep growing and growing and growing until we hit the 99.9%, or down here in percentile land, the 99th percentile, which means, right, that 98.999% of people are lower than you on something else. And this is a really handy little graph because you have an assignment in the near future that will ask you to explain percentiles. So that'll be very happy for you to have this little chart. And so I think something that needs to be said here is that they're not sort of standalone graphics. When you look at cumulative percentages, which add up over time, right? 0.1, 2.3, 15.9, 50, 84, 97.9, 99.9. If you'll remember, that pretty much coincides with the groupings of these standard deviations together, right? 0.13, 2.14, 13.59. When you start adding these together, 13.59 plus 2.14 plus 0.13, you get that 15.9. You start adding all this together, you hit 50%. Remember, 50% is the mean, median, and mode when you're in a normal distribution. It's also the 50th percentile. Remember, median is 50th percentile. So again, concepts that they're not going away, you got to remember them. And then they just grow, right? Because it's a cumulative percentage. You keep adding on to it. That being said, even though at 3 standard deviations you hit 99.9%, the 99th percentile is a little lower than that. Because between 97.7 and 99.9, 99th percentile means that you are hitting on everything. Everything below that is lower than whatever it is you're at. Okay, so we're going to work out an example of this. So we have, in this example, 10,000 people visiting a shopping mall over 12 hours. And you're supposed to be taking and finding the 30th percentile. So when do we hit 30% of the visitors that have arrived? and B, estimate what percentile visitors have arrived after 11 hours. So this is two different directions to take this question, right? We're going to tackle A first, of course, but in general, what you're saying is that tell me how many people make up the 30th percentile, and then at 11 hours, what percentile is that? So this is working this problem one way and then the other way. So we're going to start with A. Keep in mind that you have these hours and you have these people. You log how many people walk through the doors and what time it is, and so we can plot that. So here we've plotted that. You have the time and you have the number of people, and from this you can figure out where the 30th percentile is because you can join them. So if 3,000 is 30%, right? If you stop and remove all these zeros, you're saying 1, 2, 3, and then you're hitting 10. Well, that's 30%. And I march myself on over to where I hit this line. Well, I hit that line at 6.5. Well, then if that's hours, then at 6.5 hours, that's the 30th percentile. So that's nice and easy. All right, so remember B was a different question. B was how many people, no, B was percentile at 11 hours. Oh, well, that's nice and easy. It's right on the screen. All right, so if B is to estimate the percentile of visits after 11 hours, if we look at 11 hours, well, we just go backwards then we say, oh, well, okay. If I knock myself this way, that's about 95%. So that's the 95th percentile. So that's a nice and easy way of actually figuring out the percentile after a number of hours. All right, so when we talk about correlations, we need to define correlations and then also talk about the strength and direction of correlations. And that's going to be really important because we're going to be asking you to visually identify the different strengths and correlations. Now, correlational research is interesting, but so you might wonder, what can we really, answer with correlations? Well, quite a lot, right? We can predict things, which is pretty important, and we can sort of answer questions about whether data that we do have, if we see a pattern emerging in it. So is there some sort of association between two variables? And you'll be able to say yes or no with correlation and have a pretty good idea of the strength of that association as well when you have a correlational value. All right, so when you think about the word meaning correlation here, you have co, which is together, and relation. So when you're looking at correlation of the data points together, positive means that they're going up together. You're increasing together. Whereas negative is decreasing. So this is going from left to right. So if you're going from left to right and you're going up, that is positive. If you're going from left to right and going down, that's negative. And that is the best way to think about this. On the screen, you're taking a look at perfect correlations. Perfect correlations means that they line up practically in a line. I got to tell you, in the real world, that is not very frequent that you will see something so perfect. The real world is messy. And we're going to be seeing some messy correlations pretty soon. So don't be surprised if you don't actually see too many of these correlations that look like this in practice. That's not too uncommon. In fact, that is in fact common. All right, so let's get going. Oh, let me go ahead and say that when you have that correlations can be positive and negative, but they are within one. So the range here is from -1 to 1, and that's it, which I now see is on this screen. Whoop. Oh well, you're getting it twice. Something that you should take a note of if you're not already familiar is that sort of an italicized R is generally the symbol for correlation. So if you happen to see the R row, that is what correlation coefficient is sometimes abbreviated as. And again, these values range from -1 to 1. If you are given something past that, then someone's playing a joke on you. That is not a real correlation. So you can't have a -1.2 or something like that. That's not legit. Okay, so something to keep in mind is that the numerical value shows how strong the correlation is, right? So a really, really strong correlation will be a high number. And don't think of negative numbers as being low in this case. So a negative high number, so a -8.9 is a significantly high number in comparison to what, like a 0.3. So the negative 0.89 will be much better than a positive 0.3. Okay, so don't try to think of them as negative and positive as being on the actual number line in the way we normally think about them. The strength of the correlation is legitimately just about the highest value number. Okay, so positive correlation, when R is going in the direction of 1 and it's greater than 0. Negative correlation when you're less than 0, so you have you start looking at negative values. When you are at 0 itself, then there is no correlation. So if you're looking at the bottom of this slide here, you'll see that in the very middle we have this no correlation. So there's a 0 here, and what that means is that I can't really draw a line. I can't see any pattern in this data whatsoever. Whereas when I look to my left, low positive correlation, I can see that they're sort of kind of aligned. There's a line there. Whereas high positive correlation, remember we're going from left to right, and I'm increasing. High positive correlation, I can practically see the line, and that's far more common, that you're going to be seeing something that resembles a line, but it's not perfect, and 1 is perfect. On the other side of this, negative correlation, going from left to right and going down, that's negative. So 0.3, negative 0.3 here. I can sort of see that I could make a line. I can see the direction that the points are going in. At negative 0.8, I can really see the line, and so we consider that high negative correlation. And then perfect negative correlation, of course, is -1, and that's practically a line. All right, so the tighter and the closer points are together, that is considered stronger. We consider, this is what I was trying to get across earlier, that you're looking at absolute value, not really the number value of it. So like negative 0.8 is still, when you're looking at absolute value, negative 0.8 is better than 0.6, right? Because it has a stronger correlational value. Because remember, these are absolute values that you're thinking about, not whether it's positive or negative. That's not the point of the correlation. So again, here's some more practice. On the far left, you're seeing a negative 0.9, practically a line. Again, going from left to right, going down, that is negative. This is negative 0.5, left to right, going down. I can sort of see a line. I can see a pattern, at least, that it's going this way. 0, there, I can't make a line out of that, really. Same idea with positive 0.5. Here we have a line. 0.9, we have a very easy to see line, and of course at 1 you can clearly see the line. All right, so I believe that we're covering this pretty well, but the high scores in one distribution are said to then be correlated with the high scores in another distribution if we're looking at positive correlations. And on the other hand, with negative correlations, you're talking about the high scores in one distribution are associated with the low scores in another distribution. And, sometimes that's not a bad thing. So let's say that, high scores on the SAT with number of teen pregnancies. That was probably going to be a negative correlation. That you'd be surprised if you actually saw a positive correlation there. Okay, moving on, when we look at no correlation, I can't really see any sort of line going either way. And I want to take this time to warn you that not all correlations mean anything. So sometimes we see correlations that are really strong, that are, seem very much so true, but they're nonsensical, right? The more firemen that are sent to the fire, the more damage is done. Well, the more firemen going to the fire, the bigger the fire is. So by default, there's more damage. You understand what I mean when these are considered spurious correlations. They're not always meaningful. So I like this one. The early elementary school years, the astrological sign is correlated with IQ, but that correlation weakens with age and disappears as you become an adult. And I can think that you might have some ideas on why that might be. So I'm sure you can think of some. There's a really interesting one I'm going to show you on the next slide. This is a little bit older now, but this is the number of Nobel Prizes won per country with chocolate consumption. Like, really? Really? So, by this estimation, we should all be in Switzerland, and we have a chance of becoming a Nobel laureate, and we have lots of chocolate consumption. So, not all correlations really make all that much sense. If you want to check some more out, I left a link in the notes section, but it's a lot of fun to take a look at spurious correlations. All right, so we're going to do some practice now. Tell me this upper left one, what is this? Is it positive 0.9, negative 0.3, positive 0.5, negative 0.8? It's negative 0.8. Remember, left to right, we're going down, and that's a pretty strong correlation. So I wouldn't say it's 0.3, because that's pretty weak in comparison to 0.8. What about this one? Oh, I think we're going... I always get myself confused. I think we might be looking at this one next. I think so. Remember, left to right, what would you pick? 0.5. Right? So left to right, it's not going down, it's going up, so that's automatically E on these two. It's not 0.9 because 0.9 is close to 1, and 1's perfect, so that's not perfect. So 0.5 is the only one that's really left to pick from. Then sometimes it is a process of elimination. All right, so the upper right-hand quadrant, what would you call this? It's left to right. Do I sort of see a line? There's kind of a line. What do we call that? Negative 0.3. So there is a line going from left to right. It is a downward trend by very little. But that is 0.3. Whereas now, obviously you know what this one is, but it's practically a perfect line. Okay, let's try this again. Right, So we have this first one, left to right. What would you consider this? Negative 0.05. And the reason why it is so low like that is because going from left to right, there is a trend. It's negative, but wow, is it all over the place. So it's so very close to 0. All right, moving on to the next one. We're down here, left to right. What direction are we looking? Okay, what value did you pick? 0.6. Well, it's the only one that was positive for us to pick from, but this is a pretty decently strong correlation. We would probably call it moderate. That would probably be a decent word to explain this correlation. All right, so this top right one, what is this? Besides like a ball of confusing. This is negative 0.2. It is better than the negative 0.05, but it is still going down, as emphasized by this line. It's going down, as is this one. You see how it's just a little bit off from 0? So this is further off from 0. It's going downward, but it's not very well formed. And then this last one is sort of a tricky one because it's not linear at all. This is, parabola. So that doesn't really fall into our little worldview at all, for correlations at least. All right, so here you go. The higher the GPA, the more hours spent studying. What would you pick? Remember, left to right. What would you pick? Positive correlation. All right, the higher the GPA, right? Higher the GPA, the fewer hours spent playing video games. So fewer. What do you call this? Negative correlation. What is the correlation between the size of the television and the average time spent watching TV in a week? Well, according to this, that's an interesting graph of really no correlation.